Hello, welcome to today's class. Today we have a very unique math challenge here. The question is how to solve this algebra s to the power of 5 equal to s to the power of 2. So let's take our solution. Okay, now look at this question. Let's just simply put down this question again and see what happened here. Now look at this question. If you think the law of algebra will work, yeah, that is a pure lie. Here we are having the base here, x, and the base here, x, and we have equality sign here. Can we now say since the bases are the same, we can equate the exponents? Of course, 5 is not equal to 2. We all know that our 5 is not equal to 2. And so that law cannot play out here. So here we will have the highest exponent is 5. So how do we solve for the 5? So this simple challenge is easy. All right, so we move this part or this quantity to the side of the equation. And so that will now give us here our x to the power of 5 minus x to the power of 2 equal to 0. Here we want to factor out s to the power of 2 from this expression here because we also have s to the power of 2 inside what we have here now. So this now implies s to the power of 2 bracket. If we use this to divide this, we are left with s to the power of 3, then minus, we use this to divide this, we're left with 1, close bracket equal to 0. Now, remember the law, which says that if we have A times B equal to 0, this will either give us A equal to 0 or B equal to 0. Remember this law? Okay, so if we consider this, we have a similar expression here. So we can now say x to the power of 2 is equal to 0, or we have x to the power of 3 minus 1 equal to 0. So if we take the first case here, so we have here case 1. Our case 1 is straightforward. Here we have our x now be equal to what? 0. So although we have plus minus here, because if we take the square root of both sides, then we produce our plus minus, but minus 0 and plus 0 are the same. So no need for that. So here we have x1 and x2 from this system here. So this is the first value. And if you put this into the original equation, which is this, you satisfy the equation. So let's look for our case 2. So we have here case 2. What is our case 2? We're taking this now. So we have here x to the power of 3 minus 1 equal to 0. Remember the algebraic identity, which says that if we have our a to the power of 3, then minus b to the power of 3, this is equal to our a minus b close bracket or to the power of a squared plus ab, then plus b squared. Remember this? Yes. So we have a similar quantity here. We can put this to the power of 3, which is still the same thing as 1. So our expression here can be written as, or this time implies that our x to the power of 3 minus 1 is equal to our bracket x minus 1 close bracket our x to the power of 2 plus our x plus 1 to the power of 2 is to give us 1 close bracket, everything equal to 0. We have another two cases here again now. So the next one now will give us our case 2 of star. So we have here case I of star. This will now give us our x minus 1 equal to 0. So we have our x is equal to positive 1. So this is our x3. Okay, so s3 1, and if we put that into the original equation again, it will satisfy the equation. So let's take our case I star star, which is this. So here we have our s to the power of 2 plus s there plus 1 equal to 0. Of course, this is a quadratic equation, so we want to solve this using the quadratic formula. We have to record our quadratic formula. Our x is equal to, here we have our minus b plus minus the square root of b squared minus 4ac everything all over 2a. So we can bring out our a and b here from here, right? So we have our a is equal to 1, 1, b is equal to 1, and c is equal to 1 also. Okay, so let's go ahead and put these values into this formula and see what this gives us in turn. Having searched for our a, b, and c, so this will now give us here minus 1 plus minus the square root of 1 to the power of 2 minus 4 into 1 everything all over 2 into 1. Okay, so this will in turn give us minus 1 plus minus the square root of 1 minus 4 everything all over 2. Easy. So if we carry out this arithmetic, this will give us here minus 1 plus minus the square root of minus 3, everything all over 2. Now if you watch carefully, we know that the square root of minus 1 is equal to iota, right? So we can bring this into the system here. So our x will now give us here our minus 1 plus minus the square root of 3 iota, everything all over 2. Easy, right? So we have two solutions from here, which is our x4 and our x5. So let's take our first one, which is x first. So we have here x4 will now give us here minus 1 plus our square root of 3 iota all over 2. Then our x5, we have x5 is equals to minus 1 minus the square root of 3 iota all over 2. Okay, so you discover that we successfully solve for all 5 roots to the exponential equation, which is our x to the power of 5 equal to x to the power of 2. So this marks the end to this simple challenge here. If you learned something from this video tutorial, then give the video a thumbs up. And if you have any question with regard to the procedure we applied in solving this math challenge, then drop it in the comment section, for we are there to answer to all questions. Remember, this is Math Prowess, and we all here love you dearly. Do not forget to subscribe if you've not subscribed. See you in our next video. Bye.